Hello all, pre-calcers, maybe some algebra 2ers for some reason are looking at this. If you are, I guess that's cool, but this is definitely pre-calc. What are we doing today in pre-calc? Well, we just finished up second period with Jim White and Leighton. Fourth period's coming up too, where we have Kyrie, we've got Megan, we've got Sylvia in there. So hopefully this practice quiz on the infamous 3.1 and 3.2 sections really helps you out so that you really crush this quiz. So let's see what's popping off. We talked about the following in this chapter so far with exponential functions. And in addition, you got a sneak glimpse of log functions and evaluating those. So we see a bit of graphing seen here where we're graphing the exponential function f of x equals 2 to the x power. This table is going to be provided for you, but these are also your 5 key points that you should really consider graphing anytime you have to. -2, -1, 0, 1, 2. So I'll show the work for this. First number I'm going to plug in for is where x is -2. My base is 2. My exponent is -2. I know that this is a negative exponent, so I can definitely rewrite this as 1 over 2 being squared. 2 squared is going to be 4. 1 hangs around in the numerator. This is going to be my outcome. When x is -2, my outcome is 1/4. That being said, when x is -1, that looks like 2 to the -1 power. It's pretty much 1 over 2. It's half, 50 cents, if you will, if we're talking money, aka dinero. Robert De Niro. Dinero is Spanish for money. So we're talking half a dollar here, 25 cents here. When x is 0, this is a crucial property. Anything to the 0 power is 1. Anything else? Yeah, when x is 1, plugging in for that exponent, 2 to the first power is just 2. When x is 2, we'll wrap this one up. 2 squared is going to be 4. We're golfing. Cool. So we've got these 5 points. Let's plot them with a y-intercept of 1. When x is 1, the outcome is 2. When x is 2, the outcome is 4. These are a little tricky to graph out here, but I'll make sure that the graph is pretty spacious so you can approximate what this is going to be. 1/2 is in between 0 and 1. And 1/4, 1/4 is a little bit closer to 0. So if we map this out, connect these, put in an arrow to show that this keeps going to the right and also to the left, we see that we have this line seen here. If you're really special and fantastic, you know that there's a y-intercept of 1 and also a horizontal asymptote where y equals 0. We talked about horizontal asymptotes in the previous chapter, and as you can see, it comes back again. So this is saying that as x gets smaller and smaller and more negative, the line will go closer and closer to 0, but not quite hit it. So the 2 things I'm looking for would be this work, and also the table. Also the graph. That's a knockout, especially if you have a calculator. Next problem deals with the fraction, same song and dance. I'm going to check -2, -1, 0, 1, and 2. I think where I see students trip up the most is when your exponent's negative. So if x is -2, you can think of this as 1/5 to the -2 power. If you really want to get crafty with this, you'll rewrite this as 1 over 1/2 being squared, which is really just 1 over 1/4. And then since you're dividing with 1/4, this is really just an outcome of 4. So when x is -2, that outcome's 4. If x is -1, that's 1/5 to the -1 power. Oh, sorry, my bad. Small blooper. This has to be 25, actually. I got my terms mixed up, but that doesn't stop you. So that's going to be way up here. So now, where were we? When we were taking an exponent of -1, this is 1/1/5, which is going to be 5. Anything to the 0 power is 1. 1/5 to the 1 power is just 1/5. Finally concluding with 1/25. So we can only graph so much of this. This one will be multiple choice, but you should still have some understanding as to how you get your values. And you have another y-intercept when y is 0, but you already knew that. There you go. The next bit here is going to be really dealing with the log functions that were covered in 3.2. If you need a refresher on those, go for it, but I think that these are pretty easy if you have the log rules on hand. When it says equivalent exponential form, this means that they want your answer to have some base, some exponent being equal to some number. So that's what that means. So one of the properties allows us to say that if we have log of some base with something in parentheses, this is equal to some exponent. So the exponential form is pretty much taking that base, whatever it was, to that exponent, whatever it was, and it's equal to whatever was in parentheses. So draw the football play here. I'll make this purple so that you don't get confused. All right, so you got the play-by-play. In this case, going to exponential form, we have our base of 5, our exponent's 3. This is supposed to be equal to whatever's in parentheses, which is 125. So your final answer would be this right here. If we take this further, same song and dance, our base is b, our exponent's 2. This is equal to 9. Although you could assume that b is going to be 3, there's no need because you're just going to exponential form. You don't have to solve anything necessarily for a variable. So that's what you need. Now, switching backwards, keep in mind what I wrote on the previous page. Exponential form has your base with your exponent equal to some number which was in parentheses with the log. So in this case, our base is 6. Our exponent's 3. The 216 is going to go with the log, so we have log of 216 with our base of, what is that, 6? I already lost track of it. 6, yeah? And then this equals 3. Going backwards. So this next bit has you guessing what this exponent has to be. So to do this, you're going from log to exponential form, rewrite it there, and then you're going to have to guess what that next number is. So you know that your base is 3. When this is taken to some number as an exponent, this should be equal to 27. So think this out. 3 times 3 is just 9. If we throw in another 3, 9 times 3, what does that get you? You're saying 27, so this maps out. So how many 3's did we have here? We had 1, we had 2, we had 3. So collectively, our answer should be the exponent, which in this case is 3. I didn't need a calculator. I just needed notes on logarithmic functions and those properties. Those were featured at the beginning of 3.2. So if you get stuck, use your notes. you won't get stuck because you're going to ace this thing, right? Same song and dance. I'm going to rewrite this. 5's my base with some exponent where this is equal to 1 over 25. Although this is a fraction of 1 over 25, I could rewrite this as 5 being squared with a negative 2. So this is a pretty clean sweep. Our answer is negative 2. If you're not convinced, you could rewrite this to exponential form like I did and then think out how that other number needs to look. If you're not convinced, 5 to the negative 2 power is really just 1 over 5 being squared, which is definitely just 1 over 25. So our answer here is negative 2. And I didn't even need a calculator, so check me out. Same song and dance. 2 has some exponent that when evaluated equals 1. Anything to the 0 power is 1, so our answer in this case is 0. See ya. Same song and dance. Our base here is this 4. When taken to some exponent, this equals the 4 from over on the right-hand side. Anything to the first power is itself, so the exponent that we need here is 1. So our answer, final 1, is 1. Problem 7 is dealing with a property that was covered in 3.2 at the beginning of the video, but you already knew that because you have those properties written down, don't you? That property is saying that if we have some number and then log as an exponent where there's the same base and some portion there, collectively it's just whatever's in parentheses. So we're allowed to say the same thing here because we have our base of 7, base of the log is 7, so our final answer in this case is 20. On the quiz, you will have to show work even though there's a ton. I'll be making sure that you write the work for the properties that you need. And of course, use your notes. If you have any questions on this, let me know. Thanks for watching and caring about the course. Let me know if you're stuck on anything.